All right, now we're doing 7Q count cubes in a Menger sponge. This is by Rasmus Ree, and 89% of people like it. So the Menger sponge is a three-dimensional fractal first described by Carl Menger in 1926. This is an illustration of the iterative construction of a Menger sponge, okay? Check that out. So let's read about it real quick before we look at the pictures some more. A method of constructing a Menger sponge can be visualized as follows. We're going to start from a cube right here. We're going to scale down the cube so that side length is 1/3 of its original and make 20 copies of it. And then we're going to place the copies so that they measure the same size as the original cube, but without its central parts. Next part of the image. So this right here. So you see, not only is this window one gone, but also the center one and all the other windows are gone too. All right? And we're going to repeat the process from step 2 for the new smaller cubes from the previous step. And we're going to do this right here. As you see, it's 20 cubes of the 20 cubes of the cube. All right? In each iteration, ergo, repeating the last 3 steps, the effect will be that parts of the cube will be removed. They'll never be added. Menger sponge will always consist of parts that will never be removed, regardless of how many iterations we do. And here's an alternate explanation. We're going to start from the cube, right here. We're going to divide each cube into 27 equal-sized cubes. Okay, so instead of making this smaller and slapping them on here, we're going to divide this and take away the middles. We're going to remove the middle cube and the 6 cubes on each side of the group of 27 cubes, second part of the image. So just like this. So this one is the same size instead of all these being the same size as this. Okay, anyway, it doesn't matter. That doesn't matter. So we're going to repeat the process from step 2 for the smaller cubes, third and fourth part of the image. Exactly. Okay, so for the task, in this kata, we will create a function that takes non-negative integers from 0 to n and returns the amount of cubes that the Menger sponge will have in that specific iteration. All right, so for 0, it's 1. Okay, for 1, it's 20. 2, it's 40. 3, 8,000. These are very, what's the word? These look like very familiar numbers, don't they? These are very familiar, aren't they? I think we've seen 2, 4, 8, 16, 32, and 64 before, once or twice while doing this. So let's get cracking real quick. I'm sure you can see what's going on here. Let's do a console.log to start with, right? Console.log 20 times 20. Let's see what happens. You don't say. Let's add another 20 to it. Let's multiply it again by 20. How about that? Let's do that. Test it. Okay, so we know what we're doing. All right. First things first. We're going to do this the hard way. We're going to say for let I equal. Hold on there, fast-a-wits. Let I equal 0. While I is less than n, we'll say I plus plus, all right? We're going to come down here and say something like this. First things first, let's declare a variable. Let's say let result equal, come on now, equal 0? No, that's for addition. 1, because it's for multiplication, all right? So now we're going to say result times equals a 20. All right, so first thing, it's going to be 20 times 1 and then to the moon. All right, so we're going to come over here and say return result. Cross your fingers. Oh, good. Attempted, oh, good. Oh, just averted nuclear war on that one. All right. Anyway, jokes aside, we can do this a different way. We can do this a few different ways. And they are integral to this coding thing, all right? So first way we're going to do it, first let's say const calc ms equals n and an arrow. So we're going to do arrow function syntax here. And we'll say something like, first let's look at this Math.pow, right? So the Math.pow static method returns the value of a base raised to a power. That is, Math.pow, x, comma, y, x to the wife. All right? So we're going to have Math.pow, the base, and then comma, the exponent. All right? So right here, Math.pow, base, 20, exponent, in. Let's see. Finally! And attempt it. All right, we're good there. And there's one more way. I don't know where to find the documentation of this. I think I saw this when I first started doing free code camp. But yeah, here we go. We're going to do, instead of Math.pow, instead of the for loop, we're going to say 20. And then we're going to say times in. No, we're going to say times in. Times in. What will that do? Test it out. It'll do what we need it to. So times is the way to do exponents without doing this. And then without doing this. I don't know exactly how this works. Or excuse me, I don't know exactly when we would use this instead of this. But whatever. No big deal. Let's attempt it. Looks good, and submit it. Almost unlocked the solutions like a dummy. All right, so you see right here, Math.pow, right here, star, right here, Math.pow, and then here's a parse int, which, I mean, I'm still lacking when it comes to full understanding of parse int, but whatever, no big deal. Let's go to mine, just me on this one. Best practice in my opinion. Very much like it, and we'll see you next time.